Alright, so we are here with question 8 of the November 2018 South African CAP Syllabus Matric Mathematics exam. And this is paper 2, and obviously question 8 is a Euclidean Geometry question. And this is just part 1 of question 8. We also have question 8.2, also Euclidean Geometry. Okay, so let's just get right into it. Now 8.1 reads, PON is the diameter of the circle. So this is a diameter with center O. Okay, TM is a tangent to the circle, as we can see, and at a point on the circle. Okay, R is another point on the circle, such that OR and PM are parallel. So OR is parallel to PM. NR and MN are drawn, and let angle M1 equals 66 degrees. Okay, so we have all the information we need in the picture. Now let's do the calculations. 8.1.1. 8.1.1. Okay, calculate with reasons the size of each of the following angles. Angle P. Okay, so angle P here. How do you think we'll get that angle? So this, pretty much all we need. We get 1 mark for the answer and 1 mark for the reason. So this is going to be just a straightforward 1 reason, 1 mark. And the reason here is, well, let's first write the answer will be 66 degrees. 66 degrees. So let's write that in there. 66. 66, that looks more like 66 degrees. Right, and the reason for that is the Tangent-Chord theorem. Tangent-Chord theorem. Okay, let me quickly just tell you what that is. So, if we have some circle, we have a tangent to the circle, and then from this point where the tangent meets the circle, we draw a triangle. Right, so let's say like that. Then if we, in this angle, if we move across the second angle, that one will be equal to this one, right? So that's what we have here. We've got a tangent, and then this angle, if we draw a triangle, will be like the second angle. So we can go 1 angle, 2 angles, or 1 angle, 2 angles. So it's the opposite angle. Doesn't matter which way around you go, it's the opposite angle will be the same. So that's the Tangent-Chord theorem. All right, 8.1.2. Right, so angle M2, so this part here. Right, so how will we calculate that part then? Let me just get rid of this first. How will we calculate this angle? Well, again, it's just a single reason, so it's just a single theorem that we need to know. And this angle will be, M2 will be 90 degrees. 90 degrees. And the reason for that is angle in a semicircle. Angle in a semicircle. Semicircle. Alright, so we know that's going to be 90. What is the angle in the semicircle? Well, it just says that if you have some diameter, right, some diameter, and anywhere from this diameter you draw a triangle, like in this case over there, then that angle will be 90, right? That's the idea. If we just look at another random circle, we have a diameter, and from here we draw any triangle, that's going to be 90 degrees, right? If this is a diameter, we draw any triangle, we could even draw it here, that'll be 90 degrees. So that's the angle in a semicircle statement or theorem. Okay, 8.1.3. 8.1.3. Ooh, man, I keep writing uglier and uglier. Okay, angle N1, this angle here. Okay, so probably the easiest way to do this is just to look at angle PMN, right? Triangle PMN, this triangle. And we know that angles in a triangle add up to 180. So we can say angle N will be 180 minus 90 minus 66. So that's going to be 24 degrees. 24 degrees. And our reason for that is the sum of angles in a triangle. So we know that adds up to 180. So you're welcome. It would be nice if you actually showed the calculation. Just show it 180 minus 90 minus 66 equals 24. That'll be good to show. But the main idea is the answer and the reason. The reason is the sum of angles in a triangle. So it's nice to look at this triangle for that. Again, there are different ways we could do this. I'm just showing you what I think are some of the shorter ways. Okay, 8.1.4. 8.1.4. Okay, so let me just write in the previous answer as well. That was 24 here, right? 24 degrees. Next question, angle O2. So now we're looking for this angle here, O2. Okay, so again we see 2 marks, so it's again going to be a single reason and an answer. And I think the easiest one is probably to use corresponding angles. So we're going to say that 66 degrees, 66 degrees, now reason will be corresponding angles. Corresponding angles. Angles. Okay, so I'm claiming this is 66 because this is a corresponding angle with this one. So again, what does corresponding angles mean? If you've got 2 parallel lines and you draw a straight line through them, then we know these 2 angles are corresponding. They will be the same. So that's exactly what we have here, right? Exactly what we have here. Let me just show you. So we've got a line and 2 parallel lines. So that one and that one. So we know that these 2 angles are corresponding. They are the same. All right. Now, question 8.1.5. Let's see, we get rid of the straight line function. 8.1.5. Now we need angle N2. This angle here. Right. So now this angle, there's quite a few ways we could look at doing this. I'm going to suggest the following. I'm going to suggest OR is equal to ON. Why? Because they're both radii, right? So I'm going to say angle ORN, triangle ORN is isosceles. Isosceles. And the reason for that is OR equals ON, and both of them are radii. Right, so a radius is obviously equal to a radius. So what do we know about an isosceles triangle? Well, we know the base angles are the same. Right, so we know this angle N and this angle R will be equal. So to calculate those angles, we can just say 180 minus this angle 66. Let's say what's left has to be divided by 2 for these 2 to be equal. So we divide that by 2. Alright, so 180 minus 66 is 114. Divided by 2 equals 67 degrees. Not 57 degrees, sorry. 57 degrees. So we know angle ONR. Let's just say angle N. So angle N equals 57 degrees. Right, and we know this part of N is 24. So angle N2 will be equal to angle N minus angle N1. In our case, that's going to be angle N was 57 and N1 is 24, which we already calculated, 24 degrees. So that gives us 33 degrees as a final answer for angle N2. Perfect. So that is it. So most of these things, you need to know some of the reasons. You need to study your theorems to know when to use them. And this is pretty much, it's a lot of study work just to memorize the theorems and then practice being able to see them in the questions. I found that to be one of the harder things when I was doing mathematics, because I found it a bit more difficult to understand these theorems than some of the algebra things. So I had to memorize them. Maybe you found a nice way and you understand exactly what's going on, and this is a topic that you really like, and that's great. If that's the case, that's awesome. Keep going with that. All right, let's look at question 8.2. 8.2. So here we have a diagram. This is drawn. Okay, all the information is given. Yep, nothing interesting yet. D is a point, ABC is a... Okay, so this is a rectangle. So they tell us A, B, C, D is a rectangle. That's important to know. And the rest is given. Okay, good. So 8.2.1. 8.2.1. Explain why FC is parallel to GH. Okay, so we know these 2 lines are equal, right? So AB and GH are parallel. So AB and GH are parallel, and that's given. We also know AB is parallel to DC because this is a rectangle. And DC is just part of FC. So FC and AB are parallel. So let's write that. I'm going to start off by saying AB is parallel to FC. And the reason is opposite sides of rectangle, right? Of a rectangle are parallel. Opposite sides of a rectangle are parallel, so that's good. And we also know that AB is parallel to GH. AB is parallel to GH. Why do we know that? Well, they gave it to us, so that's just given. And now if AB is parallel to FC and AB is also parallel to GH, then we know that FC must be parallel to GH, because both of them are parallel to AB. All right. Question 8.2.2. 8.2.2. Calculate with reasons the length of DM, because we need this length. So let's notice a couple of things about DM. Just erase that part there. About DM. So we know DM is, well, the point M is where the diagonals of the rectangle intersect. And what do we know about intersection of diagonals of rectangles? Well, diagonals of rectangles bisect each other. So that means these things are all equal in length, right? Because this bisects the other diagonal. Okay, so that's one thing that's very useful to know. So that means if we find one of these lines, we can have the other one. So first thing I see is we have this length, this length, this length. We're missing AC. So if we have AC, we can divide that by 2 to get the length of each of these things. Right, so let's find, how do we find AC? Well, we just saw in the previous question that FC is parallel to GH, which means that these two triangles, let me write that down. So triangle AFC is similar to triangle AGH, and our reason is because FC is parallel to GH, right? FC parallel to GH. Okay, so let's actually just put the parallel line in there. So now we can see these two are parallel. So that means the ratio of this to this is the same as this to this. Right, so we can write AF, the ratio of AF to AG is the same as the ratio of AC to CH. AC to CH. Okay, let's plug in our values. So AF is 20, AG, not AG, FG, this must be FG. FG is 15, and then AC we don't know, and CH is 21. Okay, we can cross multiply, so 20 times 21 is 420, and 15 times AC is just 15 AC. Divide both sides by 15 and we get 28 equals AC. Okay, so we know this is 28, and we know DM is half of AC, but let's just write down why we know that. So let's say DB equals AC, and a reason for that is diagonals of rectangle are equal. Okay, diagonals of rectangle are equal, and then we can say, but DM is half of DB, and a reason for that is diagonals bisect. Diagonals of a rectangle bisect. Let's just write bisect. I don't have a symbol for bisect. Okay, diagonals of a rectangle bisect. Right, and we know what AC is, so we can just plug that in. So DM equals half of DB, which is the same as AC, so that's half of 28. So then DM equals 14. And that is it. Okay, again, if you used any other methods or a different ordering of things to get to the answer, please let me know in the comments below, and we can have a discussion on what is the quickest or most efficient or most understandable way. Great, and I'll see you again for question 9.